If the clouds disappear, and we hope they are, then after the talk and the book signing, we'll have the telescopes open for you guys to enjoy the skies. Orion is up with the Orion Nebula. If we can see that, that is fantastic. Comet Lovejoy is up. We have that in the database so we can see the comet, hopefully, tonight if the clouds stay away. And a number of other deep sky objects that we can do. Right now, I turn it over to Andrew for about a 45-minute presentation he promised.
Well, hello everybody. My name is Andrew Planck, and I am a retired middle school teacher, but I did not teach astronomy, I did not teach science. I am a French teacher, but I've had a passion for astronomy for the past 50 years, and I've spent the past 10 years writing a book on the moon, which has just been published. And so I've got good news and bad news. The good news is we're going to learn a lot about the moon tonight. The bad news is I couldn't manage to have the moon in the sky tonight so that we could look at it. So I apologize for my disgraceful lack of control over celestial events.
In your defense, Andrew, we may do a last-minute schedule change, though, too, so it's not entirely your fault.
Oh, okay. All right. So I'd like to welcome you to the Little Thompson Observatory. It is one of the neatest observatories on the planet. Now, I realize that might strike you as a somewhat excessive statement, but what makes LTO so unique is the fact that we do something that no other observatory does. And we make ourselves available to the public every night of the year. The scientists and the pointy heads have to go somewhere else. Just regular folks can walk through our doors. We have a public night once a month, but all you have to do if you want to take advantage is go onto our website. It's easy to remember. It's called starkids.org. Just go onto our website and find a date that's open and just put your name down. Tell us how many people are in your group, and this entire observatory with the two wonderful telescopes and the services of highly skilled volunteers are at your disposal. And it's all free of charge. We do gratefully accept donations. There's a donation box on the back wall. But we are yours every night of the year. Now, I ask you, how cool is that? This is such a wonderful service that this observatory provides for the community. Now, before I get into talking about the moon, I'd like to give you a little bit of background history about the universe so that you have a little better idea where the moon and all this other stuff came from. Now, a scientist some time ago, a famous scientist said, the universe is not only weirder than we think, it's weirder than we can think. Now think about that statement just for a minute. Everybody here knows somebody who's pretty weird, right? But of course, none of them are here in this room tonight. But even those people cannot wrap their minds around. They cannot conceive of how weird the universe really is. And I need your help to demonstrate one of the weirder aspects of the universe. Now, this is something I usually do for kids, but I've discovered that adults secretly enjoy it also. So, if you'll indulge me in a little bit of foolishness, everybody take the palms of your hands and give me a little drum roll on your knees. Bada, 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 bada. Now give me a low growl. Grrr. Okay, louder, louder, louder. When you hear the crash, everybody stop. Louder. Ah! I love doing that. It brings out the inner kid in me. So, what just happened? What just happened? An event called the... Give them some help. The Big Bang. The Big Bang. Now, believe it or not, this is an artist's depiction of the Big Bang. Something tells me it didn't really look like that, but he tried. So, when did the Big Bang happen? If you don't know, give me a rough guess. When did it happen? Anybody? Yes, what do you think? 16 billion years is pretty close. That's excellent. It was, to split hairs, it was 13.8 billion years ago. I'll take 16. That was good. So now here's something else that's pretty weird about the Big Bang. And this is something that it's impossible for me to wrap my head around, and you may find it a little difficult. And if you've never heard this, you're just flat not going to believe it. At the very instant of the Big Bang, the entire universe, not only our own galaxy, which contains 100 billion stars, but all of the galaxies in the universe. And how many galaxies do you think there are in the universe? Wild guess. Anybody? Yes, ma'am. 50 galaxies? Well, we need to keep going. Thank you for trying. It's a little bit larger than that. What do you think? Not quite. 50? What do you think?
No. It was 59. I picked 59.
Okay, I didn't hear you.
200 billion.
Okay, that is excellent. A little bit large, but you're in the ballpark. There are 100 billion galaxies in the universe. All of that material, now this is wild, all of that material was contained in a space that was no larger, I'm glad you're all sitting down, than the nucleus of an atom. Now try and wrap your mind around that. I can't. I accept it because people who are older and wiser tell me that's true. The few that are older and the many that are wiser. But all of that material in a space that was smaller than the nucleus of an atom. So what happened in the Big Bang? What was the result? It created, well, obviously it created the universe, but it didn't just spew out all of that stuff you see on the wall there. It didn't spew out stars and galaxies and planets. It only created two things: hydrogen and helium. That was it. The universe consisted of 75% hydrogen, 25% helium. So you might be scratching in your head and thinking, well, where did all this other stuff come from? Planets and comets and bugs and plastic combs and Twinkies. Well, first we got to have stars. Got to have lots of stars. So at first in the universe there were these large clouds of hydrogen gas floating around. And as you know, every physical object in the universe has a gravitational attraction for every other physical object, even when they're very small. Even atoms of hydrogen will find they are attracted to each other through their mutual gravitational pull. So in these clouds of hydrogen gas, the atoms start to interact. They start pulling themselves together, and they get denser and hotter and denser and hotter until the internal temperature reaches about 30 million degrees, and then a wonderful thing happens. A star is born. Now I have sad news for you. Stars don't live forever. Even stars die. Our sun has another 5 billion years left, so you don't need to run home and pack your bags. We've got some time. And at the end of our sun's life, it'll start to get bigger. It will get so big that, terribly sorry, the Earth will be entirely incinerated. It will get so large that it will fill up the radius, the orbit of Jupiter, and then it will shrink to a white dwarf, about the size of the Earth. And then it will just slowly die out. The fires will slowly die out because it's run out of its hydrogen fuel. However, when a star has 5 or 8 times the mass of our sun, then its death is quite spectacular. It goes supernova. So those stars, they do not go gentle into that dark night. There is a massive explosion that is greater than any explosion the universe has known besides the Big Bang. And a wonderful thing happens there. When a supernova explodes, all of the other elements on the periodic chart, besides hydrogen and helium, are created in the fires of a supernova explosion. Sorry, I got behind myself. That's a supernova explosion, and this is the remnants of a supernova explosion. This is called the Veil Nebula. And if it were summertime, we could take you up and show you the Veil Nebula. But this cloud, yeah, wrong button, sorry. This cloud, the remnants of a supernova explosion, this is carrying all of the other elements throughout the universe at a speed of 1,000 miles per second. And eventually all of these elements will mingle with the other hydrogen gas clouds that are in the process of just creating stars. And all of these elements will start to clump together, and then they will form planets and comets and bugs and plastic combs and Twinkies. So everybody reach up and touch your hair. You probably never have thought of this, but you have just touched material that was created in the fires of a supernova explosion several billion years ago. In a very real sense, we are children of the stars. So, where did the moon come from? Shortly after the Earth was formed in this accretion process that I just explained, there was another Mars-sized object in the neighborhood, and it was on a collision course with the Earth. And it slammed into the Earth in an event known somewhat with tongue-in-cheek as the Big Whack. And the Mars-sized object destroyed itself and destroyed a large portion of the Earth. And all of this debris went into orbit around the Earth and eventually coalesced into the moon. Now, something that we take for granted, and as a result we never bothered to ask, we all know there are light and dark areas on the moon, but why are there light and dark areas? While the moon, for a long time, the moon was entirely in a molten state. It was just holding together in a big round glob. And the heavier elements in the moon sank toward the center, and these heavier elements were also of a darker color. They sank toward the center, and the lighter elements rose to the surface like aluminum. There's a lot of aluminum on the moon, and these elements were lighter both in color and in weight. And then later, when the moon became solid and it solidified, there were the comets and asteroids slammed against the surface of the moon. Like, for example, there was an asteroid here that blasted out this huge crater, and it opened up cracks and fissures down to the molten zone, and this darker material rose and entirely flooded these large basins. And so now that's the scientific reason for the light and dark colored portions of the moon, but scientists don't know squat. The real reason that we have light and dark colors is so that they can entertain the imaginations of children. So how many figures can you see in the moon? There's a man in the moon, there's a beetle, there's a rabbit, and there's a lady. See what you can find. Just look at that for a few seconds. Okay, maybe this will help you. So, here's the man in the moon, here's a beetle, here's a rabbit. My favorite is the lady, because the lady looks more like a lady than the man in the moon looks like a man. Can anybody see the lady in the moon? Take a look at this. So compare the two. Very clearly, we've got a lady here. Here's her eye, her nose, her mouth, her hair, and her chin, and she's even wearing a diamond brooch around her neck. That's the crater Tycho. So the dark areas were called by early astronomers and scientists, they were called seas. And the reason they were called seas is that they genuinely believed these dark areas were liquid H2O water seas and oceans. But they also, in addition to entertaining the minds of children, they provide a very important function for us today. And if you're an observer of the moon, you want to learn the names of the 10 major seas, just like astronomers have learned the names of constellations so that they can kind of figure out where they are in the sky and where objects are that fit into different constellations. And so the seas are tranquility. The Latin name is fecunditatis, but that's a mouthful to say, so everybody just calls it, fertility. And then tranquility, serenity, the Sea of Nectar, the Sea of Crises, the Frigid Sea. Mare Imbrium is the Sea of Rains. Oceanus Procellarum, the Ocean of Storms, the Sea of Clouds, and the Sea of Moisture. Now, everybody is particularly familiar with tranquility because that's where Neil Armstrong landed. I am frequently asked when I'm showing people the moon through a telescope, is it possible to see the flag on the moon? Well, the short answer is no, it isn't. Not even the Hubble telescope can see the flag on the moon. Technically, it is possible, but you need a really big telescope. You have to have a telescope that has a mirror that has a that is 3.5 miles in diameter and gives you a power of 8 million. So we're not quite there yet, but probably someday we will be. So you've got a new telescope. What kinds of things can you see on the moon? Well, the most exciting objects, of course, are craters. How do they form? Well, scientists used to think that they were all formed by volcanic activity. They thought volcanoes were going off all over the moon. The Apollo programs proved that that was not the case. And so we have a very different understanding of the moon now. There are 3 types of craters that are on the moon. There are simple and complex and basin. The simple craters, like up here, they're small objects. They're all under 10 miles in diameter, and they're just smooth bowls. A simple crater that all of you are familiar with is Meteor Crater in Arizona. Now, Meteor Crater was created 50,000 years ago when a meteor that was 160 feet in diameter slammed into the Arizona desert at 10 miles per second and blasted out this hole that's 3/4 of a mile in diameter. It released 20 megatons of energy. Now, if you're like me and most folks, you can't relate to the term 20 megatons. You just know it's a lot of energy. Let me help put that into perspective for you. The Hiroshima bomb, when it went off, it leveled a city. Now, try to imagine 1,500 of those bombs going off at the same time. That's 20 megatons of TNT. And that's what created Meteor Crater in Arizona. Now, complex craters begin They're larger than 10 miles. They go up to 200 miles. The larger they get, the more complex they become, and the more interesting they are to look at. The classic features of a complex crater are it has central mountain peaks, it has stair-step terraces, and they have ejecta blankets, also called a glacis. And these central mountain peaks, how are they formed? When the projectile smashes against the moon, there is sudden compression and rebound. When it smashes against the moon, it pushes all the material down like a huge spring, and then there is an instant rebound where all the material flies up above the surface of the moon, and then when it lands, it creates these central mountain peaks. Now, believe it or not, we see this process happening every day. Or we could if our eyes were quick enough. In a single drop of water, there's compression and rebound, there's a central mountain, there's a multi-ring basin, and a depth to diameter ratio that is similar to most craters on the moon. My favorite trio of complex craters is the Theophilus trio. It's just east of the Sea of Theophilus trio, just east of the Sea of Nectar around day 5. And Theophilus is the crater that's on the north here. And I've discovered that there is an illusion here. A lot of people don't see this as a crater. They see it as a plateau, and they can't force themselves to see a crater. I can't force myself to see a plateau. It's very much like the young woman, old hag illusion. When you look at this picture, a lot of people will immediately see a young, beautiful woman. And a lot of people immediately see an old, ugly hag of a witch. And some people can see both. How many of you see the young woman? Okay. How many of you see the old witch? Okay. So let me point them out. Now this will take quite a feat of the imagination on your part, but I want you to imagine me as a beautiful young woman. All right? Now I'm going to turn my face and I'm going to be looking in this direction, so you just see the side of my face. And so here's her cute little nose, here's her eye, this is her ear, this is her chin, and she has a black velvet choker around her neck. Now, this will be easier for you. Imagine me as an ugly old witch. I'm now going to turn my face so that it's in this direction. And here we have, this is the witch's eye. This is her nose with a wart on it. This is her mouth, and this is her chin. Young woman or old hag, is this a crater or a plateau? Theophilus is a classic complex crater in that it has central mountain peaks, stair-step terraces, and an ejecta blanket, and there's an incredible 3-mile drop from the highest peak to the floor below. And the north wall, after the crater was formed, there was a huge landslide, and this north wall collapsed and crashed into what was still at that time an entire sea of lava. And it raised a tidal wave that raced across 60 miles, slammed into the south rim, and which was 3 miles high, and spilled over into the area beyond it. And even with small telescopes, you can see this smooth lava here, and where the lava crashed beyond the crater. One of everybody's favorite craters is Plato, located here just north of Imbrium. It is 60 miles in diameter. It has a smooth chocolate pudding floor, but something is wrong with this crater. And the thing that's wrong is that a crater this size always has central mountain peaks. So where are they? Believe it or not, they're still there. They're 1.5 miles high, but they are entirely buried in the lava flows that spilled over when the Imbrium Sea was created. A wonderful thing happens on Plato at early sunrise. The rim peaks are incredibly jagged, and at early sunrise, the shadows of these peaks are cast onto the floor of the crater so that it looks like the outline of an entire city with spires. Another interesting kind of a crater is called a floor fractured crater. And there's something that should strike you as being wrong with this crater also. It does have a central mountain peak, but what's unusual is that the crater is very, very shallow. Compare it to Tycho. Look how deep the floor is on Tycho, and look how shallow this is. Now, on floor-fractured craters, what happens is that the lava underneath, after the crater has formed and solidified, lava pushes up and actually raises the floor a couple of miles. And there's such a stress and strain on it that these arcuate cracks open up around the edge of the crater. Which brings me to one of my favorite pictures, and considering that this is a presentation on the moon, this will look a little out of place. It's a picture of a cherry pie. My mom was born on February 22nd, George Washington's birthday. And when she turned 94, instead of baking her a cake, I baked her a cherry pie. I certainly hope somebody is still telling their kids the story about how George Washington, when he was a little boy, cut down his father's cherry tree. Well, when I took the pie out of the oven, I'm going, I've seen this someplace before. And so I went back and I looked at my pictures of lunar craters, and sure enough, it looked very similar to the crater Pitatus that I just showed you. And for exactly the same reasons. There's these cracks that opened up because of the change in the elevation of the floor. The only difference is that in the cherry pie, when the lava cooled, the lava in this case being the cherry pie filling, the crust sank. And my pie crusts are not the light, delicate things your grandma made. They are really solid creations. They're made out of pure butter and flour and sugar. But basically, for the same reason, these cracks opened up. There's even a central mountain peak and even a tiny little crater hole. This is where I stuck in a toothpick to see if it was done. And then I had a wild idea. There is a website called LPOD, Lunar Photo of the Day. It's a professional website for astronomers who take good photographs of the moon to send their photographs in, and if the moderator of LPOD likes it, he'll publish it. And you know, I sent this in, and I knew his reaction was going to be, this guy's wacko. I've got a serious website about the moon, and he sends me a picture of a cherry pie. Well, believe it or not, he published it. My mom's cherry pie made the big time. So I went over to the nursing home where my mom was living, and I told her, I said, Mom, right at this very moment, astronomers all over the world are sitting around talking about Jane Planck's cherry pie. She was very pleased. So craters are such a popular subject that people lose sight of the fact that these large dark basins are also craters. They're just so large we don't think of them as craters. Now this one, Mare Imbrium, the Sea of Rains, was created 3.9 billion years ago when a meteor that was 60 miles in diameter slammed into the moon at 10 miles per second and blasted out this hole that was 720 miles in diameter. And it opened up cracks and fissures down to the molten zone, and so all of this lava came swelling up, and it entirely covered the Mare Imbrium. And lava on the moon is quite different than lava on the Earth. It has the viscosity of hot maple syrup, so it flows very, very quickly. So, in a sense, the ancients weren't so far wrong when they called these liquid seas. They just had something else in mind. Do you remember the drop of water I showed you a little while ago? The most important feature about large basins are these multi-ring features that show up. When a basin forms, it always has multi-rings. And the advantage on the moon is that these rings are then frozen into place as mountain ranges, and we can see them billions of years later. Now this again is Mare Imbrium, and it has three multi-ring features. The inner ring is almost completely flooded over, but you see it right here. These are the Spitsbergen mountain range. The middle ring starts with the Alps and continues here, but it's buried. And then the outer ring is the Caucasus and the Apennines. The Apennines are an incredible mountain range. And you can see them quite clearly even in the smallest telescopes. And the highest mountains in the Apennines are an incredible 18,000 feet. That's nearly 3.5 miles, providing the best skiing in the solar system. The Sea of Nectar also has a nice multi-ring feature, and it's called the Altai Scarp. You can see here clearly this is a ring feature. Here's the Sea of Nectar, and at one time this ring feature went all the way around the Sea of Nectar. And the Altai Scarp is 300 miles long and 3 miles high. Wrinkle ridges are a neat feature. They were created when lava flows cooled, and the best wrinkle ridge feature on the moon is called the Serpentine Ridge. It's located right here in the Sea of Serenity, and they're created when the lava flows cooled, and like breaking waves that will sometimes reveal coral reefs that are right below the surface of the ocean, the Serpentine Ridge is revealing an entire mountain range that's in the Sea of Serenity. Now, astronomers have called this feature, which is also visible in very small telescopes, the Serpentine Ridge for a couple of hundred years. Now, in the 1960s, the International Astronomical Union, in their wisdom, officially changed its name to Dorsa Smirnov, which is a pretty good indication why astronomers don't make good poets. And they're the same folks who recently demoted Pluto to a minor object, so they are not on my list of favorite people. There are several valleys on the moon, and they form differently. There are two ways that valleys form. And one type of valley is called a graben. And grabens are formed when two parallel fault lines split apart with such force that the terrain in between drops. And here is the most famous graben on the moon. It's called the Alpine Valley. It is 120 miles long and 6 miles wide. Can be seen again, no matter what size telescope you have, you can see the Alpine Valley. Now, grabens also exist on the Earth. As here in the Rio Grande Rift. And you can see the similarities here. This was created by two fault lines that split apart, and you've got the river in the middle. And up here in the Alpine Valley, if you look very carefully, you can see that there's a rill running down. And this is created by lava that was flowing and cut out the channel. The second way that valleys are formed is called basin sculpting. And this, again, is the Sea of Nectar. And when it was blasted out, huge mountain-sized boulders took flight in a straight line and landed several hundred miles away and formed the Rita Valley. The Rita Valley is the longest valley on the moon. It is 300 miles long, 12 miles wide. It is longer than the Grand Canyon. The difference is that the Grand Canyon took millions of years to form. The Rita Valley was blasted out in a matter of seconds. Sinuous rills, you see this one right here, are fascinating objects. This is Hadley Rill, and when lava flowed from a nearby volcano, and you can see, just sort of make it out, the volcano is right here, it cut a channel in the terrain. Then, because it gets very cold at night on the moon, a crust formed over the flowing lava, which continued to flow through the resulting lava tube. And eventually, after the lava stopped, sometime after that, the hard roof that formed as a crust collapsed, and we see these open sinuous rills. Now, Earth also has lava tubes. Some of them are quite small, and some of them are quite large, as in Australia's Barker's Cave. Schroeter's Valley that you see here is the best sinuous rill on the moon. Again, you can see it easily through the smallest telescopes. It begins also at a volcano which is called the Cobra's Head. It is 100 miles long, and at the height of its activity, believe it or not, it carried 10 million tons of lava per second. Another neat feature is the straight wall, visible through any telescope. It is a fault line which has given way. It is 70 miles long and 1,000 feet high, and it's visible on days 8 and 9 of the lunar month. Now, the moon can be profitably viewed from day 3 of the lunar month through the full moon and beyond. But the very best days to observe the moon is around days 6 and 7, because at that time, sacré bleu, c'est fantastique, because it is sunrise on the moon, and all of the craters and the mountains throw these long, lovely shadows that profile them. You can see them in just exquisite, wonderful detail. Now, this photo does not do justice to what you can actually see. You actually need to put your eye to an eyepiece, which reminds me of a funny story. One of our volunteers, not too long ago, was showing a middle-aged lady her first view ever of the moon through a telescope. And as she bent over and looked through the eyepiece, her jaw dropped open, and she said, "Oh my God, how long have they known about this?" "Oh, about 400 years. "Well, they should have told somebody." She was absolutely swept off her feet, as you will be if you have never seen the moon through a telescope. Now, there are 10,000 craters on the moon that are within the grasp of even a modest telescope. And you need a personal guide. This book takes you by the hand and guides you to the most interesting objects that you can see on the moon every night of the lunar month. When you open the book, on the right side of the page, you'll see the descriptions of the objects that you're looking at. On the left page, you have an opportunity to make notes and do drawings, and then a month later you come back and add to your notes and your drawings, because every single time you look at a crater, you will see more stuff. And this is so cool. A man by the name of Charles Wood, who is a writer for Sky and Telescope magazine and is the country's leading authority on the moon, agreed to write the foreword to my book. And so, in Charles's own words, what are you waiting for? Grab a telescope, this book, and a pencil, and get out under the stars. Thank you all for your kind attention.